Here's a system of 3 equations and 3 unknowns. It's written a little bit funny. I want to put it into a matrix to solve it. So what I'm going to do is write it so that all my variables are showing. So this first equation has no x's minus 1y minus z equals 0. And then this is x plus 0y minus 3z equals negative 1. And negative x plus 3y plus 0z is equal to 1. And so if I put this right into an augmented matrix, it's going to be 0, negative 1, negative 1, 0, 1, 0, negative 3, negative 1, negative 1, 3, 0, 1. So the matrix is kind of sparse. They call matrices sparse if they have a lot of zeros in them. And now my goal is to get ones here, here, and here, and zeros in the other places, here, 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 and here, which is not going to be possible with these rows written in this order. So I'm going to swap a couple of rows. I'm going to just, I guess I'll swap row 1 and row 2. Zero, negative 1, negative 1, 0. Oh, sorry, this is a plus y, so this should be plus 1. And that's a plus 1. Let me erase that. Plus, and that's a... Okay. Now maybe I should have stopped this and tried again to make a video that looks a little bit better, like I'm not totally incompetent. But that is really, right there, sort of demonstrative of the nature of solving systems with matrices. You make little transcription errors here and there, little arithmetic mistakes here and there, and it can just throw the stuff off completely. So it's a kind of a task where you have to be diligent, I guess is the word. So I hope I have successfully swapped rows 1 and 2 here now and gotten the typo corrected. So now I'm gonna, my first goal is usually, unless I'm really pushed in another direction, to work on this first column and get a 1, 0, 0. And so I have a 1 here, good, I have a 0 here, I want a 1, a 0 there. So I'm gonna add row 1 to row 3. So row 1's not gonna change, I'm using it, but I'm not doing anything to it. And of course we're totally ignoring poor row 2 here. So I'm gonna do this plus this, negative 1 plus 1 is 0, 3 plus 0 is 3, 0 plus a negative 3 is negative 3, negative 1, 1 plus negative 1 is 0. And then, so I got the first column looking like I want it. The second column, generally I want to get a 0, 1, 0, which is almost like that. I just need to get a 0 here. So I'm going to do that by adding negative 3. I'm going to use this 1 to get rid of this 3. I'm going to do negative 3 times row 2 and add that to row 3. So row 1 is not going to change. Row 2 is not going to change. Row 3 is going to change. This plus a negative 3 times that is 0. This plus a negative 3 times that is 0. This plus a negative 3 times that is 0. This plus a negative 3 times that is 0. Okay, so we ended up with something a little weird here. Again, we have a row of all zeros. So I'm going to translate, and this row of all zeros basically means you don't have any extra information in that third row, because this says 0 times x plus 0 times y plus 0 times z is equal to 0, which is the same as 0 equals 0. It doesn't add any information. So basically I've whittled this 3 by 3 system down to a system with just 2 equations and 3 unknowns. This is 1x minus 3z equals negative 1 and y minus z equals 0. So I have 2 equations and 3 unknowns. This is underdetermined. You can't find one solution for this thing, because if you gave me a value for z, I could give you a value for x and a value for y, and we'd have a triple of values that work in all 3 of those equations. And we've looked at this before. We did this in a previous video. So I'm going to solve this equation for x, this equation for y, and so I can say x equals z can be anything. So what we do is we say z is equal to some parameter. I'm going to call it t, in which case y has to be equal to t, and x would have to be equal to 3t minus 1. And so there's my solution. And I have infinitely many solutions here, because like I said before, if you gave me a z here, I could give you the corresponding x and y. You give me a t, I can give you x, y, and z. When t equals 0, you get negative 1, 0, 0. That would work in this system, in all three of the equations. And you can check, this is a little bit harder to check than if you have a unique solution, but not tremendously hard. I mean, if you check these two in the first equation, y is t, z is t, so t minus t is in fact 0. X minus 3t, so x would be 3t minus 1. Minus 3t would be negative 1. Negative x would be negative 3t plus 1. Plus 3t would be 1. And so you can check that. I just checked it verbally, but you can check actually algebraically by plugging in, and should always do that when your system is consistent, when it has at least one solution. Okay, very good.